Hi everyone, welcome back to part 2 of our introduction to polynomials. So today we're going to talk about factoring polynomials. So in the last lesson we saw that we could take two polynomials, multiply together to get one large polynomial. Today we're going to do the reverse, where we take one large polynomial and break it down into factors. So some things that you've learned about factoring polynomials in the past. A lot of times students tell me it's hard. They forget a step. Some do it perfectly every time, but that's unrealistic. So we practice. Okay, I'll explain to you why we do the steps, why mathematically certain things work, and things to remember. So here I have a list of 4 ideas, concepts to remember that will help you. Idea number 1. If it says factor completely, we're going to have to factor out the GCF, so I always do it first. Okay, look for the GCF first. If you could pull out a factor out of all of the terms, it'll make the term smaller, more manageable, and it's something we have to do anyway. Then, depending on how many terms it has, so if it's a trinomial, if it's got 3 terms, we're going to use something called a generic rectangle. You might know it as Xbox or unfoiling. The names aren't really important. The process is. And we're going to specialize if it's got 2 terms, it might be a difference of squares problem. And if it's got 4 terms, it might be a grouping problem. So I'm going to show you all of those today. So let's look at this trinomial. I'm going to show you how the Xbox method works. First thing I see is I got 3 terms, good candidate for Xbox. Also got to check, is there GCF? So 2, 10, 12, GCF is 2. Step 1, factor out the GCF. Now my numbers are smaller. Instead of 2x squared, I got x squared, 5x, 6. Now, here is what we do. We're going to make a box and an x, and this is just a process to help us figure out the outside of the box, which is the factors. So last lesson we put the numbers on the outside and we got an answer inside. Today we're going to put our answer inside and get the factors on the outside. Now, mathematically, every diagonal in this rectangle should multiply to the same thing. So this diagonal multiplies to 6x squared. It's comprised of the first term, x squared, and the last term, 6. So they always go diagonally across from each other. Now the other 2 boxes are the mystery. It's what we have to find out. Now we know they have to add up to 5x, because if inside does not add up to x squared plus 5x plus 6, then I have a different problem I'm working on. But it also has to be true is this diagonal has to multiply the same thing as this diagonal. So this diagonal, whatever these 2 numbers are, have to multiply to 6x squared. And that's where my x comes in. So 6x squared comes from 6 times x squared. But these 2 numbers on the left and right also have to multiply to the top. So I like to put a multiplication dot or an x up there to say multiply. Okay, and they have to add up to 5x. Okay, so I like to put a plus down here. So I need to think of 2 numbers that multiply to 6x squared and add to 5x. And there should only ever be one combination, and the more practice you have, the faster you see it. So in this case, I know my numbers are 2x and 3x. They add up to 5x. So 2x and 3x add up to 5x. They multiply to 6x squared. They can go in my box. Now, the nice thing about this is since it's a rectangle, they can go in either spot. Doesn't matter. I generally like to put the left one in the bottom left and the right one in the top right, just a habit. Done it for years. Doesn't make it more right or more wrong. And now we have enough information to figure out the outside of the box that something times something else got us inside. Now, what is it? Now, here's how it works. Each row has a GCF. That should be this number, or this variable. The GCF of x squared and 3x is x. The GCF of 2x and 6 is 2. Same thing with the columns. 3x and 6 has a GCF of 3. Now, another way I like to look at it is kind of like a puzzle. If I found that this is an x times x is x squared. X times 2 is 2x. 2 times 3 is 6. And as long as all the multiplication checks out, I have my two factors. So I pull the GCF of 2 out, and then I have x plus 3 and x plus 2. And now I have a fully factored quadratic. We're going to learn in future lessons some of the things we can do with this quadratic once it's in factored form. So that's just the traditional three-term polynomial that we factor. Now we also might have a difference of squares problem where it's two terms. See down here is an example, 9x squared minus 4. Now there's a few key features to look for if we're going to use this special factoring technique. First off, it's got to have two terms. It's got to be a binomial. Binomial means two terms. Second, there's got to be subtraction in the middle. And each term has to be a perfect square. So we know the square root of 9, we know the square root of 4, we know the square root of x squared. You're going to see plenty of problems like this and start getting used to what numbers show up. We know the square roots of all of these numbers I've listed here and more. Now I'm going to show you why the rectangle method works, and then we'll talk about the shortcut. So if we were using the rectangle method, okay, we could write this as 9x squared plus 0x minus 4. And do the same steps as last time, where we have 9x squared and negative 4. We multiply them to get negative 36x squared. This 0x is the bottom, so I need two numbers that multiply to negative 36x squared and add to 0x. So think about which two numbers those might be. Now you may have gotten them, maybe not. Those numbers are 6x and negative 6x. So you put 6x in one box, negative 6x in another box, and you do the GCF method to find the outsides. And with that, you get 3x plus 2 and 3x minus 2. And the order is not important. I could have put the 3x minus 2 first and the 3x plus 2 second. The order of the factors inconsequential. But what's really cool to see here is the square root of 9x squared is 3x. The square root of 4 is 2. And the difference of squares method says one is going to be a plus and one's going to be in minus. So that these 6x's, this 6x is going to cancel out with this negative 6x. So if you see two terms, we could skip the box. You could always put plus 0x or plus for the third term, but you don't need to. If you see a difference of squares problem, you can do this just using our shortcut, that it's the square root of the first number plus the square root of the second, the square root of the first number minus the square root of the second. And that's the shortcut. Now our last factoring or special factoring technique is called factoring by grouping. Okay, so first thing I got to notice is got four terms. So four terms here. That'll tell me the box method doesn't make much sense. Difference of squares is problematic. So grouping is probably where I'm going. Now this has a few steps that we'll practice. So the first step, okay, I want to separate it into two groups. So the first group is the first two terms. The second group is the second two terms. So the first two terms I can pull out a GCF. So the GCF in these first two terms is x squared. I factor it out, and I'm left with x minus 2 if I take x squared out of both those terms. I do it again for the second pair of terms. This time I can pull out a 5, and I'm left with just x minus 2 after I factor out a 5. Now notice that what's left is the same. That's always going to happen if I can do factoring by grouping. So this x minus 2 and this x minus 2 are always going to match up. They might not be x minus 2s, but whatever they are, they're going to be the same. And now what I can do is write the GCFs as a factor. So I can do x squared plus 5, and then x minus 2 is the other factor. Kind of undistributing here, or unfoiling. That's what this method's doing. Okay, that's all it's doing. It's basically taking a unfactored expression and rewriting it in factors that can be multiplied together. So now it's your turn to try a few. I recommend pause the video, try it 5, 10 minutes, whatever you need. We go slow at the beginning, we practice, we know which ones we get right. When you're ready, unpause the video, I will show you the answers. Okay, here come the answers. Okay, the top one required a difference of squares, required GCF. You get 8 times x plus 2x minus 2. The second one, once again, GCF. This one would use the box method, the x box. Third one, GCF again. Then we're going to do grouping. And then the last one, maybe you tried the box and it was unfactorable. Nothing worked. And I agree. Not all quadratics are factorable. So if you create a random one, it might not be factorable. We're able to practice and check it using our methods, but sometimes quadratics aren't factorable. And that's the introduction. That's how we multiply polynomials and how we factor them. And we're going to use this factoring skill throughout the entire chapter. So let's do some more practice and then come back for the next lesson.